Hi, in this video I'm going to go through question 7 on Math 2008. So in this question we're dealing with Oxwords. So these are sequences of the letters A and B which are constructed according to these three rules. So the sequence of no letters is an Oxword, and if the sequence W is an Oxword, then the sequence that begins with A followed by W and ends in B is also an Oxword. And if the sequences U and V are Oxwords, then the sequence U followed by V is also an Oxword. And all Oxwords are constructed according to these rules. And they also tell us that the length of an Oxword is the number of letters that occurs in it. And so, for example, AABB and ABAB are both Oxwords of length 4. So in the first part of this question, we need to show that every Oxword has an even length. Okay, so here are the rules that we can use to make these Oxwords. So if we look at rule 1, then the sequence consisting of no letters, well, that's just going to have length 0, right? So that word does have even length. And then when we make other words, we're going to start off with this word with no letters, and then add letters using rule 2 and make the words longer using rule 3. So if we're starting off with this word with no letters, then we have a word with even length. And if we start from there and we use rule 2, then we're adding the letters A and B. So because we're adding 2 letters, if we started with a word of even length, then the length of the word we have at the end is still even. And if we use rule 3 on these words with even lengths, then we see that if we're using 2 even length words and then we put them together, then that word is still going to have even length. So we can only form even length words, and therefore every Oxword must have even length. Okay, and now for part 2, they want us to list all of the Oxwords which have length 6. Okay, so here are the rules that we can use to make the words again. So let's think about how we can build up words with length 6. So we're going to start off with the word that doesn't have any letters, and then we can use rule 2 on that to get a word of length 2, and this is the only word of length 2 we can make. And now we have this word, we can use rule 2 and 3 to make some 4-lettered words. So if I used rule 2 on this word, then I get AABB. And if I used rule 3 on 2 of these types of words, then I'm going to get ABAB. Okay, and now for words of length 6. So either I can use rule 2 3 times, which would be the same as starting from this word and using rule 2 twice, and that will give me the word AAABBB. Or I can start off with one of these 2 words and use rule 2 to add 2 letters to it. So if I did that to this first word, then I just get this one again. Now if I did it to this second word, then I'd get this word. And now we can use rule 3 with this word and one of these 2 to get some more 6-letter words. So if I used this word and this one, I can either get ABAABB if I put the 2-lettered word first, or I can get AABBAB if I put the 2-lettered word at the end. And if I use this word with this one, then I'd get ABABAB. So these 5 words are our words of length 6. Okay, so now for part 3 they say, let W be an Oxword. Is the number of occurrences of A in W necessarily equal to the number of occurrences of B in W? Okay, so here are our rules for making the words. So again, if we start off with the first rule, if we're looking at the words consisting of no letters, then that has the same number of A's and B's. It has 0 of either of them. And so we're building words starting from this empty word which has the same number of A's and B's. So if we have a word that has the same number of A's and B's, and we're doing rule 2 on it, then we're adding an A and a B. So we've added the same number of A's and B's, so the resulting word is still going to have the same number of A's and B's in it. And if we're using rule 3 with two words that have the same number of A's and B's, then when we put these two words together, we're still going to have the same number of A's and B's. So therefore, from our rules, we can only make words with the same number of A's and B's. And so there are the same number of A's and B's in W. Okay, so now they say we can assume that every Oxword can be written uniquely in the form A, W, B, W dash, where W and W dash are both Oxwords. And for part 4, they say for n greater than or equal to 0, let Cn be the number of Oxwords of length 2n. And they want us to find an expression for Cn plus 1 in terms of C0, C1 up to Cn. Okay, well, Cn plus 1 is just the number of Oxwords of length 2 times n plus 1, so 2n plus 2. And they've told us this, so they must want us to use it in some way. So from this we know that every word of length 2n plus 2 can be written as AWBW dash. Well then I guess that means if we are wanting to find every word of length 2n plus 2, then we can just find all the different possibilities we can have for W and W dash. So if I say 2L is the length of W and 2L dash is the length of W dash, because remember these two are Oxwords and Oxwords have to have even length. Well then we know that the length of this word is going to be the same as this left hand side here, because these two ones are from the A and the B, and the 2 and the 2L dash are from W and W dash. And we know that this length then has to be equal to 2n plus 2. Well, now we can cancel the 1s with the 2, and we see 2 times L plus L dash is the same as 2n, and we can cancel the 2's to see that L plus L dash must be equal to n. So if we wanted to find all of the possible choices for W and W dash, then we just need to figure out how many different ways there are of choosing their lengths so that this equation is true, and then for each of those lengths, how many different words there are that we can choose W and W dash from. Okay, so say I choose an L, then I know that L dash must be n minus L, because L and L dash have to add up to n. Well, once I've chosen L, then we know there are CL words of length 2L, and there are Cn minus L words of length 2L dash. So for this particular L that we've chosen, you see that in total there are CL times Cn minus L words for W and W dash. Okay, and also we could have picked L to be anything from 0 up to n, and so we see that the total number of choices for words of length 2n plus 2 is equal to this, where we're summing L from 0 to n, and for each particular L it's equal to this many words. Or that just means that Cn plus 1 is equal to this sum.